Hi folks, we're going to take a look at page 386, number 10. So here they give us these two vectors, and we notice that there's unknowns in each of these vectors, and they want us to find those unknowns under these two conditions. So in the first one, where these two vectors are collinear, and in the second scenario, when the vectors are perpendicular, and they want to know if the answers we get are unique, meaning is there only one answer to solve the particular problem, or possibly more than one. All right, so let's take a look at collinear. Now, let's recall we would have used another term for this. So we would have referred to two vectors being parallel, okay, but that's identical to being collinear. So we have to think that if two vectors are parallel to each other, okay, they could have different magnitudes, they could have the same or opposite direction. So you realize that in order for two vectors to be parallel or collinear, they need to be scalar multiples of each other, and those scalar multiples could be negative. So essentially, in number one, I need to have vector A written as some scalar multiple of vector B. Of course, I could have done it the other way around, B equal K times A. Okay, so in other words, A, which is 2P8, has to be able to be written as K times Q 412. But what I want to do is I want to focus on the Z components, because there's no variables in either of the Z components in these two vectors. So I definitely need, in order for these to be scalar multiples of each other, for 8 to be equal to K times 12 if I focus on just the Z components. So here, K must be equal to 8 over 12. There's no other choice, or in other words, 2/3. All right? So here, because we need them to be scalar multiples of each other, and because the Z components are fixed, we see that there's only one value of K that will make this work. So in this case here, the answers are unique. Now, of course, they didn't ask us for this K value, they asked us for P and Q. Okay, so if we want to find, let's do the first one here. Let's use the X components. We have 2 would have to be equal to K times, so 2/3 times Q. And so Q is just going to be equal to, we'll multiply both sides by 3 over 2. So 2 times 3 over 2 multiplied by the reciprocal. So here we just end up with Q being equal to 3. And for P, we can do that via the Y components. The Y component in the first vector has to be equal to K times, so 2/3 times the Y component in the second vector. Okay, and here we get 8 over 3. So here, these are the answers we get for P and Q, and they are unique, meaning there's only one set of P and Q that will make these two vectors collinear. All right, let's take a look at part 2. All right, and let's take a look at perpendicular. Now, this is where we're going to use something we've learned recently. We know that if two vectors are perpendicular, their dot product has to be equal to 0. So that's what I'm going to use to solve this here, is if I want them to be perpendicular, A dot B has to be equal to 0. So in other words, we've got 2P8 dot Q 412 has to be equal to 0. So let's find the dot product. So we've got 2Q plus 4P plus 8 times 12, 96, equals 0. Okay, and what I see here is I end up with an equation in Q and P, okay, that I can't really solve any further. There's infinitely many values of Q and P that satisfy this equation. But if it satisfies this equation, it means the dot product is 0, meaning the two vectors are perpendicular. So in this case here, this is not unique. So if we want to come up with a couple of examples, let's simplify it first. So I'll divide both sides by 2. So this is Q plus 2P plus 48 is equal to 0. Okay, so here let's say I pick Q equals 0, then I can determine that P is equal to negative 48 over 2, so negative 24, and there's one set of solutions. Notice here I'm picking easy stuff. Let's pick P equal to 0. Okay, so here Q is just going to be equal to, well, that's nice and easy, just negative 48. I could pick Q is equal to 1. Okay, So that means 2p is equal to, so this is negative 48 minus 1, negative 49. So p is equal to negative, 49 over 2, 24.5. And I could keep coming up with, infinitely many answers, because there's infinitely many combinations of p and q that satisfy this equation. So here, answers are not unique. Okay, and in fact, I've shown that by finding 3 different possibilities. All right, so just to recap here, what was needed to solve this problem was to realize that if 2 vectors are to be parallel or collinear, they have to be scalar multiples of each other. And if 2 vectors are to be perpendicular, their dot product has to be equal to 0. And using that led us to our answers. All right, that's it for this one.